Some focus here. Alright, so this is the same little levitating style rotor that I showed in my last video. You see, I bought some solar toys, took the coils out of those. And right now, the way this thing is configured, that slight rotation that it's getting is caused by this driver circuit from one of the solar toys, just like one of these guys here. Except instead of the solar cell, I've got a 1.5 volt button cell on there, and through a 1 mega ohm potentiometer, which is all the way up right now. So I've got 1 mega ohm resistance between this battery and the circuit. You can see with that amount of resistance, it is drawing 1.2 microamps. But amazingly enough, it's still actually able to get this very slight novelty rotation. I thought that was pretty awesome. It's pretty useless as is there, but if I put some type of enclosure on it and sit it somewhere where I can just run it from microamp or so, have it spin, it's still pretty cool, I guess. But I guess I wanted to show the gradual effect of the gradual increase in the current draw here as I lower that 1 mega ohm resistance from that battery, and also kind of explain these coils. I've tried a bunch of different things so far, and I still haven't decided what the best way is for me to drive this. I mean, there's so many different possibilities. Really just all depends. I mean, I could run it from the little solar cell, which I was doing, which, I mean, that's pretty cool. But that will only run in the sun or from light. And the way I have these coils here, the four that you see, the 4 coils that you see that are symmetrical are actually all in series, same polarity, and those series connections are coming out down there, as you can see. Those 2 leads which are not hooked up. The only drive coil right now is this non-symmetrical one right here in the corner. That is the only coil that is hooked up, and its leads are right here that are going to this circuit. So basically what I ended up doing was, the first thing I tried was driving this rotor from those 4 series coils through this circuit, and it actually basically what I found out was at this type of rotation it would actually work better from how I'm driving it right now. That 1.2 microamps would actually get it going a little faster than that. However, when you drive the circuit a little harder, let's say about 30 microamps or closer to 200 microamps, which is what it runs at full blown in this configuration, it actually doesn't spin as fast. It doesn't achieve as fast as a top speed as if I simply drive it from the 1 coil. And I came to believe that was simply due to the very sensitive circuit and the way I was introducing a higher inductance. And with the shape of these magnets, basically what would happen is as it gets up to speed and the magnet approaches the coil, it wants to create a change in inductance, much sooner than it needs in order to create a clean fire and a clean rotation. So ultimately it builds up to a certain speed where it just can't achieve the same RPMs as it could with a single coil. And that also has to do with the self-induction going on, where those 4 symmetrical coils in series induct in a way where if I was to short out those 2 leads right there, this thing wouldn't rotate at all, damn near, no matter what I was driving it with. It just completely halts. So at any rate, I just found it to be better to drive it from that 1 coil, and I'm going to use these 4 symmetrical coils as a generator setup, which I've already tried several different things already. For example, crank this up, drive it a little faster. I can put maybe 3 volts or so charge on a capacitor like this, 1,000 microfarad. Was doing that earlier, couldn't quite figure out or decide upon the best way to go about all of that. So right now I'm just still in the stages of testing different things, seeing how it reacts, and I decided I would show this video just to kind of show an idea of what's going on here. So I'm going to move this meter a little closer, and so we're still coming off this button cell here, and that's actually pretty brand new. I got that from some dollar store deal. So that's about 1.5 volts right there, pretty fresh, 1.2 microamps. That's what it's doing. So it pretty much bottoms out around there because I can give it a few kilo ohms resistance change before you actually see any current increase. I'm burping back here in the background. So let me bump it up to about what it wants, about right there, about 20. Let's say about, if I can find it, about 30 microamps. That's a good spot that it likes. So right there at about 30 microamps, it starts to kind of build up a better kick. Builds up decent speed. And you can bump it down to about 20 or so. But that's about a pretty good low region to get, decent rotation. Something that's not completely, absolutely slow. So let's turn it all the way up. You can see what it wants to do is draw a peak of maybe a couple hundred microamps or so. And as far as this meter is able to tell, about a low of about 50 or 60. So it dances around between those two regions, presumably just because of the rotation of the magnets and how the circuit works. But let's just say at that rotation, it wouldn't be too difficult for me to get a pretty good charge into a capacitor from those 4 generator coils. So I have yet to figure out exactly how to incorporate that. But I just wanted to show how that works, and you can turn that down all the way, and it will still run from less than 2 microamps. But only way to actually show that is to dead stop it. You dead stop it, so right now none of the magnets are aligned with the coil at 1.2 microamps. It takes a very long time to actually get it up to speed. It might oscillate, rock back and forth very slightly before it actually is able to overcome inertia and get that. So you saw that little slight kick there. That probably wouldn't be enough to offset that inertia it already had going on, but eventually it will settle out, get some momentum, and maintain that rotation. Or you could just give it a slight push yourself and just hurry up that whole process, and it will stay spinning. But I thought that was pretty cool. So like I say, I have yet to really fine-tune an idea or a way to run this, but the whole point is it takes extremely low input. So let's just say if I can manage, about right here is about 5 microamps, then I would assume, since it will rotate slightly off 1.5 or so, then I can get a slightly better rotation from this that will maintain rotation. And this is the type of input that I could probably get more than this from let's just say one of those tritium keychains. I mentioned that on Lid Motor's channel, and was curious if anybody tried that, and he told me that Laser Saber was actually working on it. And I know that Laser Saber would have no problem getting that to work at much higher RPMs with a bigger rotor with his easy spin setup, because I know that I could drive this off so little. Likewise, I can use that solar cell with this pot in between and bring it down. Where normally it wants about 20 microamps, I can bring it down to about 5 or 10. It'll still run. So same deal. Um, so you can see now it's getting close to the point where it might actually get some good rotation here. But as of now, it's just kind of see, it'll spin one way, and as that capacitor builds up and then a magnet approaches, it'll give another push and kind of cause it to spin the other way. I haven't quite decided which is better, push or pull in this scenario. It really depends on your magnets. But in this scenario, push might be a little better. It just sort of has to overcome and get the timing right to the point where it's no longer pushing the magnet away in the opposite direction as it's coming. You just want it to kind of latch on and kick it in the same direction, which is what has eventually started to happen here. And the end result is when it finally equalizes and gets up to about its top speed, it will be noticeably faster at the 5 microamps than it was at the 1 microamps, obviously. But I'd say that the built up solid rotation at 5 microamps, that's something that I could be happy about and say, okay, that's a cool toy. When you look over and you see it spinning, you think, all right, cool, cool. You know, it's pretty cool. It runs off so little, it'll run forever. Likewise, another thing I did was I used those generator coils to run back to the source capacitor and use those capacitor instead of a button cell. And when I did that, I was able to use the straw maneuver and spin up this rotor and put some charge into that main cap, maybe about 2-3 volts, then kick this up to about 20 microamps and then run it that way, which was sort of similar to the easy spin motor setup. Of course, in that scenario, it will actually rotate, get some pretty good speed from a little over 3 volts, as long as you're pushing about 30 microamps, but then it'll drain the capacitor from a few volts down to about a volt pretty quickly, at which point, though, it will continue to run this motor at about a volt from a few microamps, and that's off like a 1000 microfarad capacitor. So that was pretty cool. So I've just discovered all these, different ways I could potentially drive this. The lower levels are what I'm trying to investigate now, which just makes more sense. The intricacy of it all, if that's the way to pronounce that. It's very important for me to understand for upscaling. Yeah, there you go. Pretty cool little deal.